In this video we're going to look at trapezoidal rule, which is a method for getting the area of irregular shapes. So we already have methods to get the area of triangles, rectangles, circles, different things like that. We don't have a method so far to get the area of something like this, which is very irregular. Let's just say this is the side section of a mountain. Okay, how would I get the area of that? Well, if I divided this up into, let's say, 3 rectangles and just went like this, it went up as far as it hit the mountain, okay, and I got the area of this rectangle, this rectangle, and this rectangle, I'd be close enough the area of the real mountain shape. How would I get it more accurate? Well, if I did my rectangles smaller, so if I did more rectangles but they were smaller, so there's more rectangles but they are smaller, and if I got the area of each of those rectangles, I'd get even closer to the real area of the mountain. Could do it again using even smaller rectangles. So as you can see, the more rectangles I use, the closer I'll actually get to the real area of that. Okay, and that's how that basically is what trapezoidal rule is. Okay, we're going to divide our section into small rectangles, and we're going to get the area of all those rectangles, and we'll get pretty close to the area of the real object. Remember, the more rectangles or sections I divide it into, the closer my real answer is to the actual answer. So here is trapezoidal rule. H over 2 brackets y1 plus yn plus 2, y2, y3, y4, all the way up to yn minus 1. What that really means is h over 2, we'll call h the width over 2, and first plus last plus twice the rest. Okay. So what do I mean by that? Well, the first thing we do, if it's not already done first, is we divide our base of the object into however many sections we want. Okay. This might already be done first. If it's not, we're going to have to do it. Right, so divide this section. Here we go. And remember all these widths. Okay, so from here to here. So from here to here it has to be the same as from here to here, so it has to be equal bits. Okay, and I'll just divide them up. Right, so I've divided it into equal sections, and each section we say is 2 centimeters. Now we're going to get the height of each section. So this is going to be 0, say 1 centimeter, 3 centimeters, 3.2, 3.6, 3.5, 3.5, 3.6, 4, and here would be 3.2. So there's all the heights, right? And all we do is put it into this formula. Here's the formula in our logbooks, but what that formula really means is this. So the width is 2. Okay, here's the width. So 2 over 2 this time. It's just a coincidence. Now, the first height is 0. Plus the last height is the first height. That's the last height, which is 3.2. 3.2 plus twice all the other heights. So all the other heights are 1, 3, 3.2, and so on. Okay. So 1 plus 3 plus 3.2 plus 3.6 plus 3.5 plus 3.5 plus 3.6 plus 4 plus 3.2. And we work that out. Okay, so just remember our bomb dash. So it'll be adding all these together first, then multiplying by the 2, then adding this to it, and then working out what this is. Okay, so we'll start from the middle out. If we were given a shape like this, first thing we should do is we'll divide it into sections. Okay, so into sections, and again let's divide it into however many pieces. Okay, again now I'm doing this freehand. If you were doing GB measure, and again you'll do your heights. Again, now this is very rough with freehand. So that's 0, and you'll measure your height. So there's 1. That's probably 1, 3, 1. Is it 4, 1, 3.5. That's probably 1.5, and so on. Okay, you understand that. What we could do then is we could divide into 2 sections. We could take this section first, use the trapezoidal rule to get that. Then take this section, use trapezoidal rule to get that. Or an easier way of doing it is actually just adding the height. So watch. So this height here is 0. This height here, we add the 1 and the 1, we get 2. We add the 3 and the 1, and we get 4. 4 and the 1.5, we get 5.5, and so on. And we use trapezoidal rule using these. And if we do that, we'll actually be able to get the area of the whole thing together. Okay, so it'll save us a bit of work. Right, so last one, a little bit different this one. We're given the area this time, and we're asked to find one of the heights. Okay. Again, we're using trapezoidal rule. You'll write down your formula, you'll fill in what we know. This time though, we do know the area, we don't know one of the heights, so we just let our height as x. Okay. The method we use for doing this is we do these inside brackets first, then we'll deal with what's multiplying it, then we'll deal with all of this bracket and we'll multiply outside. Okay? Because remember our BIMDAS, we don't want to make any mistakes with our multiplication. So here we go. Well, 4 over 2, we can change that to 2. 0 plus 5 plus twice everything in the bracket. So 4 plus 3.5 is 7.5 plus x. And that all equals 52. Remember, we let it equal the area. Okay, so next up, we have 2 outside the bracket. Inside we have 0 plus 5 plus twice everything else. So 2, 7.5 is 15 plus 2x is 2x. And that will equal 52. Okay, so now we can add whatever together. So 2 outside the brackets, 5 and 15 is 20, plus 2x equals 50. So now we will multiply what's inside the bracket by what's outside, so we get 40 plus 4x equals 52. A bit of algebra here, take 40 away. Take 40 away. We're left with 4x equals 12. So divide by 4, divide by 4, we get x equals 3. So the height of this is 3 centimeters. Okay, that's it guys, thanks.